Hello everyone. What's up guys? So, how are you guys? What's going on over there? Please share your attendance once. What happened guys? Is everything alright? Okay, hey Senapati. Okay, hi Kohima. So guys, how is your life going on other than the studies? Are you enjoying it? Anything new that you have done in some previous days? Why Senapati? What about you Shillong? Is all okay? Is everything going on fine? Okay, cool. So guys, first of all tell me that what are we discussing in the previous class? Okay, is all the students has joined the class or still some are on the way at every centers? Tell me the topic that we were discussing in the previous class. I think I have, okay. I think I have given you homework as well in the last class. How many of you has attempted, how many of you has done that homework? And what was the homework? Do you remember something? Shillong, Senapati, Kohima. Guys, what I have told you to do? Yeah, periodic table. I have told you to draw the periodic table, leaving the spaces. Spaces as in that you need not to write the elements on those boxes. That was the homework. Okay, Shillong, as I can see you, raise your hand, those who haven't done this work. Raise your hand. Those who haven't done this work. Okay. Okay, those who has done this work, Shillong can raise their hand. Students at the Shillong. Okay. There are some students who just look at the others and raise their hand. And how many of you are telling a lie? How many of you are telling a lie? Now you can raise your hand. It's too bad if you haven't done that work. See, today I have told, I have told you that in the next class we will learn the periodic table, all the elements present in the periodic table. So first of all, we will start learning those elements. And second thing, the topic that we have left in the previous class will be continued. So first of all, tell me, what was the topic that we were discussing in the previous class? The topic that we were discussing in the previous class? Do you remember the topic? Okay, magic number was the topic. Shilong, do you agree that magic number was the topic that we were discussing in the previous class? Yeah, confirm once by looking into your notes. Okay, so magic number was the last topic that we were discussing. Cool. So guys, first of all, let's start with the periodic table. Okay. So those who haven't drawn the periodic table yet can kindly do that work. Okay. I think so that in the modern periodic table we have discussed that there are 4 blocks: S block, P block, D block, and the F block. We will learn all the groups separately. Okay. And we'll start with the S block elements. Okay. So guys, what you have to do, you have to just look at your screen, okay, and observe that what I'm trying to do, okay. We'll learn a simple mnemonics or simple tricks to remember those elements, okay. So, periodic table. In the periodic table, the first block is S block. Guys, please do not copy this, okay. First of all, observe this, and after that I'll give you time to copy this, okay. So, see how to draw this one. At last, we will compile that. See. There should be 7 boxes, 2, 3, 4, 5, 6 and 7. Okay. Then this is your period 1, period 2, period 3, period 4, period 5, period 6 and then period 7. Okay. S block. Okay. This is your group 1 and then look at this. This is your group 2. Okay. So S block has got only 2 groups. Okay. So first of all, I am writing the elements present in these groups. So here, hydrogen, lithium, sodium, potassium, rubidium, cesium, and then francium. These are the elements present in the group 1. Okay. In the group 2, we have got beryllium, magnesium, calcium, strontium, barium, and then radium. Okay. So these are the elements present in group 2. So now we have to learn 2 things. First, all these elements, and second, their atomic numbers as well. Okay. So guys, for group 1, you have to remember this one. for group 1, you have to remember this one, that Helena, okay, Helena is the name of a girl, knows Ruby, Cassie, and Farah. Okay, Helena knows Ruby, Cassie, and Farah. Okay, so what will we got from here? See, these are the first three elements that we have written over there. These are the first three elements: hydrogen, lithium, sodium. Here you will get the potassium. Here you will get the rubidium. This is your cesium, and this is your francium. This is how you can simply memorize the group number 1. That's, you have to simply remember a sentence that Helena knows Ruby, Cassie, and Farah. And guys, one more thing, that you might replace these names as well. If name of your friends can fit over there, then you can definitely use those as well. Okay? So this is the trick for the group number 1. Easy? You can copy this. Copy this. And guys, one thing. First of all, make me clear that, is it visible to everyone? Is it visible to everyone clearly? These boxes and the elements written here. Okay. So guys, you will first of all prepare these boxes, and after that you will write that mnemonic over there. Okay. And copy this one. And after that we will write the mnemonic for the group 2 as well. Is it easy to learn? See, we have to learn 118 elements. Okay. And guys, remember, make those boxes in such a way that you can put numbers as well over there, because we have to write atomic number as well. Okay, we will learn how to write the atomic numbers. Okay. Have you done that? Shillong, Senapati? Okay. So guys, let's move on. Now, this is for group 2. Okay. So this is the mnemonic for this one, that better managers can sing bad rap music. I hope so everybody is aware to that. Okay, so this is like that, a better manager can sing a bad rap. Okay, so this is just a possibility. Okay, now see what will we get from here, that from better we will get the beryllium, from here we will get the magnesium, this is your calcium, strontium, barium, and then radium. Better managers can sing bad rap. Okay? Is it fine? And guys, you're most welcome that if you learn this in your own mother tongue as well. If you can make the mnemonics for yourself as well. See, this is done by me. Okay? Even I have learned all this in Hindi as well. Okay? So, if you can make these mnemonics in your own language, you're most welcome. Okay? You can do that as well. But the thing is, we have to learn. Is it clear to everyone? Senapati and Kohima, have you copied that? Okay. So now it's time to write the atomic numbers. See. Group 1. Okay, for the S block, you have to remember these digits, magic numbers, which is 2, 8, 8, 18, 18, and 32. Okay? See. Hydrogen, lithium, sodium, potassium, rubidium, cesium. Once again. Group 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and then francium. Okay, to write down the atomic numbers, you have to just remember the first element of the group. Here, the first member is hydrogen, whose atomic number is 1. And after that, what you have to do? You have to use these numbers. 2, 8, 8, 18, 18. What you have to do? You have to add 2 into this. See? 1 plus 2 is what? 3. After that, in this, add 8. On adding, you will get 11. Now, add 8 again. Okay? After adding, you will get 19. Then add 18 to this. After adding, you will get 37. Then add 18 again. On adding, you will get how much? 55. And then add 30 to this. On adding, you will get 87. So guys, if you remember the atomic number of first element, you can write the atomic number of whole group. Okay? So atomic number of hydrogen is 1, lithium is 3, sodium is 11, potassium 19, rubidium 37. Okay? Then cesium is 55 and then francium would be 87. Okay? You have to write this one in your periodic table, okay, in those boxes, in the same manner, so that it would be easy to learn. Okay. Now, let's shift to the group 2. See, group 2. Group 2 starts with second period. So this is beryllium, magnesium, calcium, strontium, barium, and then radium. Okay? Again, you have to remember those numbers, which is 2, 8, 8, 18, 18 and 32. Now one important thing, that as this group starts with period number 2, so you cannot add 2 into this. So the atomic number of beryllium is 4. Okay, so here we will start with 8. Okay, 2 won't be added here because this is starting from the period 2. Okay, so we'll start with 8, 8, 18, 18 and 32. Okay, so I have given you the atomic number of beryllium. Now it's your turn to write all the atomic numbers. Write down the atomic numbers and then we will confirm that. Copy this and write down the remaining atomic numbers. After completion of that, you will just intimate me and then I'll start writing it. What you have to do? Then add 8 to this one, then add 18 to this one, add 18 to this one, and then add 32 to this one. Okay, we have got an answer. Kohima and Senapati, guys, have you done that? Have you completed that? Okay. So let's begin. So answer for this one is 12, 20, 38, 56, and then 88. This is the answer. So guys, now can you memorize the group number 1 and 2 of the S block? Is it easy to learn? Okay. Oh, hi CC4. So guys, let's move on. So this is about the group 1 and 2 of the S block elements. Now S block is over. Let's move on to the P block elements. Okay. P block. Okay. In the P block elements, we have groups from 13 to 18, 14, 15, 16, 17, and then 18. Okay. This starts from period number 2. See, 2, 3, 4, 5, 6, and 7. Okay. This is how your P block looks like. Okay. Between S and P, there is D block as well. We will talk about D block later on. Okay. So this 13, 14, 15, 16, 17, and then 18. But one thing, this is your 15, 16, 17, and then 18. Actually, 18 starts from period 1. That you have to remember. Okay. So I have already told you that you have to draw this one in your copy. Okay. So right now you need not to draw this. Okay. You can do that at your home. We will simply start with the elements, okay, of the groups. So guys, let's begin with the group 13. Okay. Now, group 13. Elements are boron, aluminium, gallium, indium, thallium, and niherium. So this is the group 13. Now the point is how to learn these elements. Okay. See, you can remember this one, that Baal, Ganesha in Thailand National Highway. See, this is your boron and aluminium, gallium, indium, thallium. Guys, remember the symbol for the thallium is Tl. And this is your NH. Please copy this fast. Done. Okay. Now the point is how we can write the atomic numbers of this one. Okay. So guys, for group 13 to 17, you have to remember this one. Group 13 to 17. Okay. The magic numbers are 8, 18, 18, 32, 32. Okay, these are the magic numbers for the group 13 to 17. Okay. See, the atomic number of boron is 5. What we have to do? We have to add 8 in this one, 18 into this one, 18 into this one, 32 into this one, and 32 into this one. Okay, do this and tell me the answer. Do this one and tell me the answer. Anyone has any suggestion or some different tricks? Is there anyone who is so creative or innovative who can give me some other trick as well other than this one instantly right now for group 13? Have you done that? Okay. So let's start. See, 13, 31, 49, and this one should be 81, and this one should be your 113. Is it the right answer? How many of you has got this answer? Shillong can raise their hand as I can see them. Okay. Very good. What about you, dear, who is sitting at the first bench on the left, on my left hand side, at the Shillong Center? Yes, you. Have you got the answer? Hi. Have you got the answer? Yes, I'm talking to you right now. Student at the first bench who is sitting like this. Yeah. Yes, you. Have you done that? Say yes or no. Okay, that's good. And hi to everyone. Okay, so guys, I hope so you are getting this concept that how we can write this one. Guys, remember that you have to learn this periodic table. Okay? Then you will be one of the few students who knows the periodic table, how to remember the whole elements along with the atomic numbers. Okay? See, most of the students knows about the S block and the P block only, but we'll learn about S block, P block and the D block with whole atomic numbers. Okay, so we have to be little bit different. Okay, so I hope so. Is it clear? It is clear to everyone. So I can move on. See, so this is the how we will deal with the group number 13. So let's move on to group number 14. And remember, in the next class, see, I'll discuss the S block and P block only today. In the next class, I'll discuss about the D block and the F block. But before the discussion, everyone has to remember these elements. Okay, there will be a test in the next class, oral test of these elements. Okay. So this is the group 14. So again, if we talk about the group 14, this is your carbon, silicon, germanium, tin, lead, and then we have got flerovium, which is Fl. And guys, remember, these elements are new. Okay, those elements whose atomic numbers are higher than 104 or 108 are actually new elements which are added to the periodic table. So these are the new elements. Okay, so guys, this is the group 14 elements. So let's see how we can remember this. And this actually belongs to a little bit to me. Okay, see, this is your chemistry sir gave serious problems finally. If you don't like chemistry, you can change the subject. Okay, but remember, subject should start with the C. Okay, don't make anything which doesn't start with the C. Okay, so let's start. This is your carbon, silicon, germanium, tin, lead, fluoranium. Okay, so this is the group 14, how we can remember the group 14. And again, I have to just remember the first element, atomic number of first element. Carbon is 6. I have given you the magic numbers, okay, for group 13 to 17. So what we have to do? Add 8 to this, 18 to this one, 18 to this one, 32 to this one, and 32 to this one. Tell me the answer. Okay, these are the answer. Okay, is there raining outside Shillong? Is there raining over there right now? Okay, so let's start with this one. We have got answers. Okay. Oh, that's why someone is looking outside the window. It's okay, dear. You're inside. You're safe. Remember, I can see you. So I'll pick anyone who is actually enjoying. See, silicon would be 14, germanium 32, SN would be 50, and then 82, sorry, this is 82, not 81, 82. And last one is your 114. Guys, am I right? Do I have written all the atomic numbers correct? Or is there any scope of correction in this one? Thank you. So let's move on, guys. This is how we will complete the group 14. Okay, let's start with the group 15. Elements are nitrogen, phosphorus, arsenic. Can anyone tell me please what is SV stands for? Can anyone please tell me what is SV stands for? Very good. Tin. Oh, it's a tin. SV is tin. If SB is tin, then what is SN? See. Where is the page? I guess so this is tin. Yeah. Antimony is the right answer. Bingo. Okay. So SB is the antimony. Guys, remember that many of the elements you can identify by just looking at their representations, but yeah, there would be certain some elements which are little bit different because they have derived from their Latin names. Okay, so SB is actually antimony. Okay, then what was the next element? There is nitrogen, phosphorus, arsenic, SB, bismuth, Vi, and then last one is your MC, which is moscovium. Recently discovered, moscovium. So now the question is how we can learn this. See, this is your newspaper are superb basic material. Okay, so we can get this one very easily. Nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium. And the atomic number of nitrogen is 7. So can you please help me out while writing the rest of the atomic numbers? Can please someone write this remaining atomic numbers? Okay, we have got one answer. Who is at the Kohima center? Kohima, Senapati, Sisepo. Guys, please share your answer. Okay. And yes, guys, one important thing that the symbols of the atomic numbers are always represented by the capital letters. If there is a single alphabet over there, if there are more than one alphabet, generally maximum it can have only 2. Okay, so second letter will always be small. First one is capital and second one will be your small letter. So yeah, I have got answers. Very good. So this is phosphorus is 15, 33, 51, 83 and 115. So this is how we can remember the group 15. Okay. So guys, let's move on to the next one. Group 16. They are also known as the chalcogens. Okay. Also known as chalcogens. Okay. So let's start with the group 16. Oxygen, sulfur, selenium, tellurium, polonium, and LV is for livermorium. Again, this is the new identified element, livermorium. So let's start how we can remember this one. This is only small size telephone lives long. Okay. Only small size telephone lives long. So, oxygen, sulfur, selenium, tellurium, polonium, livermorium is Lp. Atomic number of oxygen is 8. Write down rest of the atomic numbers. Write down rest of the atomic numbers. Okay, Kohima has given the answer. Good. Sisipur is also there. Shillong, have you done that? Senapati. Okay. So, let's begin with the answer. This is your 16, 34, 52, 84 and 116. Any confusion? So guys, let's move on. Okay. Now, let's start with the group 17. Halogens. So, halogens are fluorine, chlorine, bromine, iodine, astatine, and then tennessine, TS, newly invented discovered element. Okay. So you can remember this one as first class biryani in Austria? In Austria. Atomic number of fluorine is 9. Copy this and write down the rest of the atomic numbers. Okay. Can anyone suggest me something better than Austria for the AT and TS, acetine and the tennessine? Any suggestion so that we can improvise this? Or no need or no scope of improvement here? Okay, Shillong has got the answer. Australia. Okay, you can do Australia as well. Actually, I have to put anatomy of tigers. This is the one more suggestion that first class biryani in anatomy of tigers. Can you relate these two terms? First class biryani. Okay, do you know what is biryani? What is biryani? I'm writing rest of the atomic numbers. Okay, this is 17, 35, 53, 85, and 117. Okay, so this is how we can memorize the group number 17, halogens. Okay. So guys, let's start with the last group of P block. 18. Noble gases. This is your helium, neon, argon, krypton, xenon, radon, and OG, oganesson. Okay, the atomic number of helium is 2, add 8, and then again 8. These are the actually magic numbers used over here. Magic numbers are actually the electronic configurations of the noble gases. Okay, so finally we are at the noble gases. So all the magic numbers would be present over there. Okay, so 18, 18, 32, and then 32. You can write rest of the atomic numbers. Copy this one. Done? Okay. Now the question is, how will you remember this? Noble gases? This is your 10, 18, 36, 54, 86 and 118. So guys, this is for you, group number 18. Okay. Use your creativity and prepare a mnemonic for the group 18. Okay. Not right now. You can take your time. Okay. This is the homework for the next class. Okay. So in the next class, you will write the mnemonic for the group 18. Okay. I want to see that how much creative you are, and then we will discuss the rest of the groups, which rest of the blocks, D block and the F block elements. Okay. First of all, quickly count the number of elements that we have discussed till now. Number of elements, total S block and the total P block. How many elements you have written in your notebook? Okay. Guys, have you counted? Only one sentence there who has counted all the elements. That how many elements do we have discussed today? The number of elements, for those we have learned the mnemonics. Only today. Okay. And what about you, Kohima and Sisipu? Have you counted? They're still counting. Wow. Actually, we have learned 50 elements today. Okay. So, so guys, this is the homework for you. Oh, wow. We have got a mnemonic right now. Who has got this mnemonic? Sisipu? We have got something, guys. See? That he never argue with Karan, Sheena, Ranu, and other girls. So guys, this is the mnemonic for the group 18. This is one of the mnemonics, and by the way, very good. Okay. You can learn this one easily by this one. And yes, still you have to make your own mnemonic. I would like to know that how many of you has attempted this one. Okay. In the next class, I want to see some other examples as well. Some other funny mnemonics over there. Okay. So guys, this is the homework for you. 50 elements for you. Atomic numbers, symbols, and name of their elements. Okay. You will learn by the next class. So, and by the next class, we will deal with the D block element and the F block element. Guys, what can you do? You can you can leave about 3 to 4 pages for the D block and the F block. And after that, you can start today's next session. Okay. So before that, let's take a break, okay, of 5 minutes, and after that we'll continue with the topic that we have left in the previous class. Okay. See you in the 5 minutes. Hey guys. So break is over. How was your break? Have you enjoyed that? Oh, next time. Okay, how much time you need for the break? Next time I'll take care of that, and I'll give you that time span for the break. Tell me, how much time do you need for the break? Okay, cool. Very good, Shilong. I'll try. I think you have written the wrong unit over there. Instead of hours, it should be minute. Next time I'll take care of it. That you will get only 2 minutes. Yeah, same here. Oh, can you please tell me why this guy who is typing at the system is after just typing it just like this? Why so? What does it mean? That you are trying to wake up or you are trying to sleep in the class? Yeah, that's better. Yeah, again, now that's better. That position is much better. Like this. And same with that guy who is sitting just the student in the green shirt. All the boys in the one row are exactly same. They're trying to copy to each other. Okay. Say hi once. There is one student who said hi with the help of the notebook. He is still shaking his notebook and saying hi. This is a new way to say hi. Wow, you're so creative, man. Oh, hi Kohima. Hi Sisipo. Hi Senapati. Is there anyone who's left? Okay, so guys, let's begin with the next topic. So guys, we have discussed about the magic numbers. I have discussed about the 50 elements. In the next class, I want that everybody should learn all these 50 elements. Okay, I'll take a test, and that test will be for the centers. Means all those centers were connected in the next class. Okay, we'll will participate in this one. Okay, and we will have a winner. Okay, and winner will get a surprise. Okay, no, so let's start. Next topic is shielding or screening effect. Do I have written the right spelling for the shielding? Is it right? Hmm. Okay. So, this is the shielding and the screening effect? No. See, I'm taking an example. This is the nucleus. This is your atom. Okay. These are orbitals actually, or orbits actually. Suppose we have got electrons. The red dots are representing the electrons. See, these electrons are present within an atom. Excuse me. Yeah, these electrons are present in an atom. So, obviously, they will feel a force of attraction by the nucleus. See, all the electrons are feeling a force of attraction by the nucleus. If I talk about the outermost electron, if we talk about this one, it is feeling net inward force, means net attractive force, like this. Okay. Why? Electron is feeling an attractive force because electron has carry the negative charge, whereas nucleus has got the positive charge. Okay. We know that opposite attracts. That's why all the electrons are feeling the net attractive force. Now, we know that electrons carries the negative charge. See, this is the electron, this is the electron, and this one is also what? Electron. So obviously that this electron which is present exactly outside, means that which is present at last orbital, will feel some repulsive force as well. Repulsive force because of the inner electrons which are present inside the, which are present just inside the its previous shell. So this is what? Repulsive force, which is felt by the outermost electron. Got it? Now my question is, if I remove these electrons which are present in the inner shell, will the outermost electron feel more attractive force or it will be remain same? My question is, if I remove the inner electrons, means there is no inner electron, then what will be the effect on the force of attraction to the outermost electron? Will it increase, decrease, or remain same? Net attractive force. This question is for everyone. Everyone has to answer. Very good. Obviously, the force will be more. Okay. So, guys, first of all, the reduction in the force of attraction due to the inner electron is known as the shielding or screening effect. First of all, make it clear that the force of repulsion, or we can say the repulsive force which is felt by the outermost electrons, and the net attractive force which is decreased now due to presence of inner electron, is known as what? Shielding or screening effect. Okay. So first of all, I'll write the statement for this one, that the decrease in force of attraction on valence electron due to inner shell electron is called shielding or screening effect. screening effect. Okay, and the net after applying the or we can say after considering the screening effect, the net attractive force we can say felt by the outermost electron is known as what? Effective nuclear charge. Okay, see, finally the outermost electron is still feeling attractive force. Okay, there is some reduction in the attractive force due to the inner electrons. Okay, so the final magnitude, or we can say the final attractive force which is experienced by the outermost electron is known as what? Effective nuclear charge. Okay, I'll write it. First of all, just copy this one and tell me, is it clear to everyone what is the meaning of shielding or screening effect? Because this has very much importance in the next topics. Okay, so I won't discuss it again over there. Okay, so you have to just make it clear over here. If you have got any confusion, you can ask me right now. I can explain it again, or I can take some other example. Please copy this first. Okay. Okay. So, next. Effective nuclear charge. It is written like this, Z effective. The net force of attraction experienced by valence shell electron. Copy, please. So guys, let's move on. Next is physical properties. Okay, in the physical properties, first of all, we'll discuss about the atomic radius. Okay, we will have some other physical properties as well, like ionization enthalpy, electron gain enthalpy, electronegativity. Okay, about that we'll discuss later on. Okay, so first of all, let us discuss about the atomic radius. Okay, so guys, let's start with the atomic radius. Listen to me very carefully. Okay, from here, the important questions will be derived. Okay, and remember one thing, in the examinations, this section is very much important. Always you will get the questions in your school examinations. as well as examinations that you will attempt after your school, means in your entrance examinations. Okay, most of the time we have to deal with the exceptions. Okay, I'll deal with the exceptions as well, which are little bit different from the general trend. Okay, so first of all, let us discuss about the atomic radius. First of all, guys, tell me one thing, that this is the structure of atom. Okay, we have draw a orbit outside the nucleus. So first of all, tell me, do the orbitals have definite boundaries or not? Do the orbits or orbitals have definite boundaries or not? Means like I have draw a circle over there. Okay, circle means that this is a boundary. Is these boundaries are sharp in the atom or not? Do the atoms have sharp boundaries of the orbitals? I think structure of atom we have completed. Shillong, what do you say? CC4, Senapati. What about your views? Views, guys? What do you think? Can anyone please tell me the definition of the orbital? What orbital is? What is orbital? Okay. So this is a discussion with all the students, and the majority of the students is no. No, they do not have any definite boundaries. Okay, good. Obviously, orbitals do not have any definite boundaries, because in the definition of the orbital, we have learned that orbital is the region in the space where the probability of getting the electron is very high. Okay. Yeah, where probability of getting the electron is very high. Okay, and see, electrons are actually electron clouds. Okay, these are electron clouds, and clouds do not have any sharp boundaries. Okay, we don't know that what reason would be there. If you have remember, I have drawn the orbital like this. If you remember that, when I was discussing orbital with you, these are the dots. See, this is how we represent the orbital, and these dots represents what? Electron cloud ultimately. Okay, so guys, the same situation was in front of the scientists when they were discussing about the atomic radius, when they were trying to find out the atomic radius. Okay, so as we know that atomic radius, to calculate the atomic radius, we need sharp boundaries, and unfortunately, we do not have the atom or the shape of the atom where we can get these sharp boundaries. So, scientists has decided that they need some other method to determine the atomic radius. Okay, so actually they have defined the atomic radius in many ways. Okay, please do not copy anything. First of all, we'll write that why we cannot calculate simply the atomic radius. If I talk about this one second, guys. If I talk about this one, if this one is true, what would I say? This is the radius. So radius is what? That it is the distance from the nucleus to the outermost shell containing the electron. This is the simple definition of the atomic radius. But as we do not have the sharp boundaries, so we cannot say this statement is right. Okay, so this was the old definition. Okay, but unfortunately this is not how it works. So different scientists has determined experimentally radius of different elements. And if we talk about the atomic radius, we have got the following types. First is covalent radius. Second, van der Waal radius. Do not copy this, guys. Do not copy this. Wait for some time. Metallic radius and the ionic radius. Okay. Just because of that one problem, we have identified these kind of radiuses over there. Okay. So, if we talk about any radius, if we talk about size of any atom, we can categorize in one of them. Okay. They will be placed in one of these categories. Okay. In these four categories, they can be either covalent, they can be either van der Waal, they can either be metallic, or they can either be ionic radius. So, finally, we have to discuss with the four radius. And before that, let's discuss about this one. Now you can start copying that. Atomic radius is the distance from the nucleus to outermost shell containing electrons. But electron clouds do not have sharp boundaries. Therefore, this statement holds true. Therefore, guys, first of all, copy this one. Okay. Okay. I'm writing one more statement. First of all, you will copy that statement, and after that you will copy the types of atomic radius. Copy this. Therefore, scientists have determined different types of atomic radius. The following are, after copying this, you will write the types. I'm writing here. First is covalent, van der Waal, metallic, ionic. Copy. Have you copied that? Okay. So the first one is covalent. Radii. This is generally used for the non-metals, okay? Generally used for non-metals. Okay? See? This is a covalently bonded atom, okay, forming a molecule. And this is distance D. Okay. So if I have to calculate the covalent radii for this one, so the radius would be half of D. It would be half of D. Okay. So we can define it as it is the half of the internuclear distance of two covalently bonded atoms, okay, in a molecule. So I'm writing the definition as well. You can copy along with me. Definition. It is the half of internuclear distance of two covalently bonded atoms in a molecule. Copy, please. Is it clear to everybody? Anyone has any confusion or doubt? Okay. Senapati, Sisipu, are you still there? I'm talking to you guys. So, let's move on. Next is your van der Waal radii. Or you can say radius as well. Okay. See. One second. Yeah, look at this. See, this distance. Let's say suppose this is d. Okay. So van der Waals radii will be the half of the distance of two consecutive nuclei. Okay, it is a two consecutive nuclei of molecules, or we can say noble gases. Okay, because they can form the van der Waals bonds. Okay, they can form the type of interaction present over there is what? Van der Waals forces. Okay, so if I write this one, so this R would be equals to half of D. Copy please. And after that, I am writing the definition of this one as well. Start copying this. It is defined as half of the distance between two successive nuclei of two covalently bonded molecule of like atoms or two successive nuclei of noble gases. Copy please. Guys, have you copied that? Have you copied that? Okay, Shillong. Okay. Next is, okay, can anyone please tell me that if I compare the van der Waals radii with the covalent radii, which one should be bigger? Covalent radii or van der Waals radii? Okay. What about you, Shillong and Sisipo? Why covalent? Guys, look at the diagram once, observe that, and then tell me the answer. Yeah, some of you has got the right answer. Cool. How many of you has got this one? Shillong can raise their hand. If you got this, Shillong can raise their hand. If you have got this, that van der Waals should have the higher value than the covalent one. Okay. The students who are just sitting at the back. And what about these students who are sitting on the right hand side of the wall? I mean, my right hand side, nearby the wall. All three boys. Have you got any confusion? Yeah, absolutely, Sisipur. Okay, very good. So now, the boys who are sitting on the right hand side, let me try, will raise both of their hand. Come on. Cool, better. Guys, okay. Do you have any problem? Is everything going fine? Okay. Let me continue this one. Where are we? What are we discussing, guys? Van der Waals relay we were discussing. Next is metallic radius. So metallic radius is the half of the internuclear distance in the metallic lattice. Okay? This is the half of the internuclear distance between two adjacent metallic atoms in a crystalline structure. Copy this please first. Okay. Look at this. This is distance d. And r would be half of d. Okay, this is the metallic lattice. Now, if I compare all three radiuses, which is covalent, van der Waal, and the metallic, what should be the order of size? Okay. That van der Waal should be biggest one, then there should be metallic, and there will be then covalent should be at the last. Anyone has got any confusion regarding this one? Is it clear to you? That's that note which is I have written for you. Then van der Waal should be biggest one, metallic should be what smaller than van der Waal but bigger than covalent. Okay. Okay. So guys, let's discuss about the general trend. We'll simply write it. General trends. Or remember, ionic radii will be discussed separately. Okay. So, okay, tell me one thing, that if we move from top to bottom in a periodic table, what should be effect on size? Size should increase or decrease when we move from top to bottom? Yeah, from top to bottom. Wow. What about you, Sisipo? Yeah, obviously, absolutely right answer, that on moving from top to bottom, size increases. Okay. See, atomic numbers is increasing. We can say shells are also increasing. That's why size should increase. Now, second important thing. If we move across the period, moving left side to right side in the periodic table, what should be effect on the atomic size on moving left to right? Okay. Okay, majority can say that why it should decrease? Yeah, it will decrease. Absolutely fine. Why it should decrease? Any reason behind that? In the Shillong, the student in the green is talking to student who is in black, if I'm correct. Okay, बेटा दोनों को पाप लगेगा. तुम लोग से बात कर रहे हो ना क्लास में बैठ के ऐसे, तुम दोनों को पाप लगेगा, बता रहा हूं मैं. Yeah, absolutely right. Guys, see, this is very much important discussion going on. Okay, and some students are enjoying with their own stuffs. Okay. Yeah, very good. Absolutely right. On moving from left to right, nuclear charge actually increases. Okay. On moving top to bottom, nuclear charge decreases, or we can say shells increases. Okay. So this is the statement, and the detailed discussion will be done in the next class. So first, you have to write on moving top to bottom, size increases because shells increases, or we can say Z effective decreases. Okay. Number 2, on moving left to right. Guys, copy this along with me. On moving left to right, size decreases because nuclear charge, or we can say Z effective. Guys, this is not ZEF. Okay, don't pronounce it like a ZEF. This is Z effective. Okay, increases. How many of us copied this? Can raise their hand. Dear, we will discuss the ionic radii separately after completion of the atomic radius of the covalent, van der Waals, and the metallic. Shillong can raise their hand and rest can write on the screen that have you copied that? Okay. Okay. I have seen few students who were has raised their hand like this. Oh, don't take it too seriously, guys. Okay. So finally, guys, that's all about for today's session. Okay. So finally, your happy hours have started now. You can enjoy your lives. So see you next time. Till then, make sure, guys, listen to me before leaving the class. For the next class, you will learn all those 50 elements, and we will learn the D block and the F block elements after that, and we will continue with this one. Okay, you have to revise all these stuffs. Okay, so till then, see you next time. Take care. Bye bye. Have a great time. See you.